and I want all of you to attend the online session so that you can listen to me, what we call that, you can listen to me freshly. I don't want it to be recorded since it involves several concepts that I need to discuss, face to face via online. Okay. Now, let me begin with the engineering statistics. So what are you going to cover in this course actually? So I don't want to go to the course outcome that we have discussed last week. So I hope by now you can refer to your course outline, which contain all the information of the class schedule, of the assessments, of the class by weeks, which topic will be covered for every week. Okay, so hopefully by looking at that, you will have your brief idea on what is the whole story about EQT271 or engineering statistics. Okay, so let us begin with the first, okay, with the first slide. Now, do you recognize this? Where can you find this, class? If you have your, what we call your textbook, on first page of your textbook, okay? Okay, you can see this particular, what I have placed in the slide. So basic to engineering statistics, and circle in the yellow cloud is turning data into meaningful insight. So the whole idea of chapter 1 is actually not to teach you actually, but because I think some of you may have gone through this particular topic before during your secondary school, or maybe during your matriculation, or maybe during your diploma if you have taken your diploma. Excuse me. So the whole idea of chapter 1 is how you are going to deal with your data. Okay, means that assuming that you don't have your own data, and then you get your data, and then you need to know what you will have to do with your data until the moment you will have to give conclusion for that particular data that you have in hand. Okay, so that's why the reminder is there, turning data into meaningful insight. So how we are going to turn your raw data into meaningful information, meaningful insight, meaningful what we call description for others to easily understand. Now, these are the chapter outline. This is the chapter outline for chapter 1. Okay, basically we are going to look at statistic in engineering, collecting engineering data, and finally data summary and presentation, which will be based on the types of variables, graphical data presentation, and numerical data presentation. Okay, so for today, I hope I can finish 1.1 until 1.2. Okay, I'll try my best not to consume 1 hour to finish everything. Okay, because I will require more time to download my video into my YouTube channel. Okay, so it will be hard for me. Now, let's say you have so for this semester, what we did is that for project 1, you will have your secondary data. Means that you will be given a set of data for you to analyze. But previous semester, what we did is that we require students to collect their own data. Means that we don't provide them with data set, but they have to find their own data set by collecting their own data. Okay, so that's why in statistics is either you begin your research with you yourself collect your data, or you can just use available data that could be from the government report, the what we call the news, what we call the Facebook, or whatever we call what do we call that, the IG or whatsoever. Okay, so in this case, imagine that now you have your data, but the question is how to turn your data into meaningful insight, into meaningful information. So you will have to figure out that. So in order for you to figure out how, so these are the things that we are going to discuss. Now, imagine you are this person, okay? You are this guy, this tall guy, okay? Standing on the ladder, trying to reach the fruits, okay? And you are now the engineer, okay? Now, what happened is that in this particular situation, you as an engineer will not be able to process your data into meaningful insight if you don't use statistics in your process. That's why I put statistic as your label here. And you as an engineer, and you're trying to get the data. And from this data, you're going to plug this fruit and then put into the basket. And this basket that fills with fruits are all the meaningful insight that you need to present to your, maybe to your boss and maybe to the board meeting or whatsoever. Okay, now the point of this slide is just to mention that you need statistics to help you out, turn your data into meaningful insight. Now, what is your role as an engineer? Okay, as an engineer, you will perform experiment. Okay, you will collect data, and then that data will be processed to explain the relationship between better and reveal information about the quality of product and services that you provide. Okay, so the main point here, you as an engineer, you will involve a lot with experiment. And then one of the result of your experiment, you will get data. And then what happened to the data is depending on you. The way you turn the data into good information is based on your knowledge of your statistics. Okay, so that will be your role as an engineer. But from the perspective of statistics, what we do actually with the data, okay, what will be the process involved in the transformation of data into meaningful information or meaningful insight? First, set clearly defined goals for the investigation. So before you even start your experiment, you will have something in mind. Why do you need to carry out the experiment? Okay, the same. Before you even collect your data, you will have to think what information that you need. Okay, and that particular information will be based on what do you want to achieve when you collect your data. So that's why you have to set your goal, why you choose or why you need to collect the data. Second, make a plan of what data to collect and how to collect it. Okay, a part of what data to collect, you should know how to collect the data. For example, for previous students, as I mentioned earlier, those students, all students previous semester will have to do survey. Okay, means that they will have to create a Google form and then distribute the Google form within their friends, and then they are going to collect data from their friends using Google form. So they know they need to use the Google form. Okay, so in your case, if you are doing your experiment, so of course you will know what kind of experiment that you will do in order to get your data. Okay, so I think you know better in this particular case. Third, apply appropriate statistical method to extract information from the data. Means that once you have got your data, okay, now you need to think how to turn your data into meaningful information. So here you will have to know few options and the statistics that you can use to help you out. Okay, and finally, interpret the information and draw conclusion. So this is the most not trickiest part, but I think the hardest part for engineering students, because most of the time they will comment and continuously says making conclusion is the most hardest part dealing with engineering statistics. So, but somehow it is necessary for you to have that particular skill. Now, what is statistic? Okay, we know that we need you as an engineer need statistic to help you out with data. Okay, now what is statistic? Okay, what is how statistic is defined? Okay, statistic is the science of data. Means that when we say science, it involves processes, it involves input, it involves output. Okay, and that processes include conducting studies or experiments through first collecting, followed by organizing, followed by summarizing, followed by analyzing, and finally making conclusion. So there will be 5 processes involved in statistics. Okay, so in your case, you are using secondary data. So are you collecting your data? Somehow yes, but you are not collecting on your own because the data is readily for you. Okay, so you are going to start with organizing your data, and then you will have to analyze, and then you will have to organize, summarize, analyze, and then finally what we call that, making conclusion. Okay, so in order to do that, in statistics there are 4 important concepts that you need to understand, and you will need to what we call inculcate this particular concept within yourself so that you can achieve to the point where you can make your conclusion based on your what we call analysis, okay, within your using your data. Now what are the 4 concepts that you should have and you should develop within yourself? We begin with the lowest level, which is the statistical literacy. What is statistical literacy? Literacy means celik. Celik means you can see. Okay, obviously when we say you can see means that you know. When people says about sample, in terms of notation, sample is, example, sample mean, it refers to X bar. If population mean, it refers to mu. The same goes to other what we call knowledge. So in order for you to understand statistics, you have to have statistical literacy. So the only way for you to have statistical literacy is by learning it. Okay. Next, after statistical literacy, you will need to have statistical knowledge. Of course, when you have learned something, when you have learned a concept, you will have that knowledge within yourself. For example, okay, population, call it as mu. Where do we calculate that? We calculate from the population subject. Now, you have that knowledge within you. So this is where the what we call the information become, the ranking of the information become higher and higher. From literacy to knowledge. Now, from knowledge, become statistical thinking. Now, whenever you need to analyze, if you have the knowledge itself, it won't be sufficient for you. So you will have to have your thinking within you. Knowing that you have the literacy, you have the knowledge, then of course you have to think. Is it true? Is it correct? Is it possible? Okay, is it is it what we call, is it sufficient? So you have to think. Okay, so this is where the thinking process came in. Whenever you wish to what we call solve some problem or analyzing some method, so you need to think about what you need to achieve from your analysis. And finally, the most important part is your statistical reasoning. This is where you need to give reason for whatever result that you obtain from your analysis. Whenever you have got your result, okay, you have to give reason. You have to make conclusion. In order for you to make conclusion, you will reflect back your data. Oh, no wonder my result become this. This is because my data is this, and this. Okay, so you relate back to your data relate to your objective, and then everything will be in order for you to do the conclusion, making conclusion of your analysis. Please stop me whenever possible for you, whenever you wish to ask me any questions. Okay, otherwise I'll just go through the slide straight away. Yeah? Now, in order for you to understand, because we know that we start with the statistical literacy, then knowledge, then thinking, then last but not least is the reasoning. And of course, you have to relate to the assessment that you will be having throughout this semester. So as you know, there will be few assessment that you will have to encounter. That will be first project 1 regarding your chapter 1, and you will have also tests and quizzes. Okay, and then you will have project 2 for chapter 5. So means that for this particular assessment, so there will be some taxonomy bloom involved. And this taxonomy bloom is actually reflecting the statistical concept, 4 statistical concept that we have just discussed just now. Okay. Now, what are the taxonomy bloom? The lowest level for the taxonomy bloom is to remember, followed by to understand, to apply, to analyze, to evaluate, and the highest level is to create. As for your EQT271, if I'm not mistaken, there are some cases where you have to create. Okay. If you can go back to your course outcome, you can double check. It's either C6. Whenever we say, for example, for project 1, it is a C4 project. It means that you will have to have this particular cognitive level in order for you to solve project 1. So when I say C4, means that you will have analyze, apply, and understand, and remember for the execution of your project. Okay. Can anyone listen to me? I'm afraid that my sound will be very slow, or is it okay? My voice?
I can hear you.
Okay,
Okay.
thank you.
Clear, very clear.
Okay, thank you. Now, if we pair this particular 4 concept of statistics with the what we call the taxonomy bloom, we can see, okay, the more we go to the higher level of the statistical concept, that is the statistical reasoning, the higher the cognitive level involved in the process. Okay, so this is just for your understanding. So that's why when we say about making conclusion, of course, there will be some thinking involved, and there will be some reasoning that you need to do for that particular equations or concept or whatever things that you do. Okay. Now, why do you move? Okay. Now, let's begin with the terms and concepts that you need to understand. Other than the statistical thinking, statistical reasoning, statistical literacy, statistical knowledge. Okay, there are terms and concepts of statistics that would be crucially important for you to remember all the time. Whenever we say or we talk about statistics, this concept should be understood well, so that you won't mistakenly talk about something, data that you have in hand. So what are the concepts? The first is variable. What is variable? We'll see later. Okay, I'll just mention what are the concepts involved. Second, variability. Third, population. Fourth, sample. Fifth, descriptive statistic. Sixth, the inferential statistic, and finally, number 7 is random sample. So these are all the terms that you need to understand. So whenever people says about some of the or one of the concept or terms, you should have in mind what are they talking about. Let us look at one by one. Now, in order for me to explain to you all the concepts, I need to bring you a scenario uh, which I think hopefully it would be easy for you to understand. Okay. what is the scenario that would be helpful for you to understand the whole concept and terms that you should know. Now, do you recognize this class? What is this? This my mouse is
Sate.
This is satay, and this satay is using what? This satay is using pencucuk satay, right? So this pencucuk satay is what we call skewer. Okay. Now, last time I bought three packages of skewer from a shop. Okay, and I did what we call simple experiment where I asked three group of students to measure the length of skewers from the packages that I bought. Okay, I have three packages of skewers. I assigned three groups of students, and each group will have one package of skewers that I bought. Now, what happened? Now, let us see. Look at this particular star here. I put star for 13 cm. What is 13 cm? Can you guess? What is 13 cm?
The length
of the stick.
Yeah, the length of the skewer. The length of the skewer. From this bottom to the edge here, it should be 13 cm. And this company, let's say this company, we call it as Wallaby. Wallaby company says that the skewers that they are producing is 13 cm in length. Is it true? Let us see. Now, as I mentioned just now, I assigned three groups, and three groups, each package should contain 400 skewers. And I asked each group to take 40 skewers out of every package. Okay, so means that group 1 will have 40, group 2 will have 40 skewers, group C will have 40 skewers. Means that from 400, I asked them to take 40 from each package. Now, I asked them to measure. Okay, so they measure the length. Okay, the length in terms of centimeter, and then as I mentioned just now, they have 40 for each package. So there will be 40 observation from each measurement. Now what happened? It turned out when they measure the length, what happened is that these are the results. Okay, so we have group A, we have group B, we have group C. And if we look at this particular table, we can't see much, right? We can't see any what we call significant differences between the data. So what happened is I put the data in terms of bar chart. So this particular bar chart is from group A, this from group B, and this from group C. Can you observe something similar from each bar chart? And what is that similar for each bar chart? Can you guess? Just try. It's okay if you are wrong. I'll just correct it. It won't be obvious from this table, but when you see here, it is obviously there are something with the data. And what is that something? Can someone tell me? Come on. Don't waste your time. I need you to answer. I need to hear one answer at least. Why is that?
skewer.
What was that?
The length of skewer is different.
Yes, correct. So what you observe now, there are differences among the skewers. I have 40 observation here. From group A, there are differences among the length of skewers from observation 1 until observation 40. The same goes to group B, and the same goes to group C, sorry. So what happened? What happened to the claim? This company's claim. The company says all 13 cm. You can sue them, right? Because it turned out that they are lying. Now, this is why all this concept in statistics, appear. Y variable, Y variability, Y population, Y sample, Y descriptive statistic, Y inferential statistic, Y random sampling. Now, from this particular understanding, we know that there are differences and we know that we are measuring the length of the skewer. Now, let us begin the concept one by one. Okay. Now, when we measure the length of these particular skewers, okay, this length is what we call variable. Okay. What is variable then? Variable is any measured characteristic or attribute of interest. So what is your interest for that particular data? So you are interested at the length of the skewer. So that length is what we call variable. And that variable in statistic is what we call as, denote as X, capital X. Okay, we call it as variable. Now, what is variability? Variability is actually came from the words variable. Okay, we know that from the data. If let's say we are talking about data set A here, so what happened here? We have what we call differences from observation to observation. So this is what we call variability. So what is variability defined as? Is the successive data values that are different each time they are measured or collected. So from observation 1 to until observation 40, they are all different, and maybe some of them are similar. Okay, but most of them are different. Now, next, population and sample. Without looking at the slide, okay, as I mentioned just now, if I want to say the population of one package is 400. As I mentioned earlier, one package contains 400 skewers. And for that, from that 400 skewers, I ask each group to take out 40 skewers. Simply say all the skewers inside the package is what we call population, because it contains all the skewers. And that 40 skewers that we choose to measure is what we call the sample. Simply say, means that what is sample? Sample is subset of your population. Is some amount of your subject from your population. That is sample. But if we look at a broader perspective, let's say we are talking about this company, Wallaby, and we know that this company, let's say this company has 3 machines, A, B, C, in order to come up with this particular skewers. And let us look at the profile of the company. Production per day, 500 skewers. Operation per day, operation per week, 5 days per week. Number of workers, 20 workers. Number of machine, 3. Monthly production, plus minus 10 million skewers monthly. Now, from this particular information, we can define our population and sample. If we wish to define the population, it should contain all the subjects or all the objects. That's why the definition of population can be defined based on daily basis, weekly basis, monthly basis, or yearly basis. It depends on the need of your what we call experiment or your studies. Okay, so in this particular case, the population for 1 day production is all for 500 million skewers. If I want to define within 1 month, so the population for 1 month production are all 10 million skewers. So what about sample then? Sample is a subset of population containing the observed object. Population just now is the entire collection. The words all reflect the entire collection. Okay. So sample, for example, if let's say the population for 1 day, then the sample for 1 day is, let's say, this 500 out of 500,000 skewers. What is the sample for 1 month? Okay, sample for 1 month, if the population for 1 month is 10 million, so the sample for 1 month you can take as maybe 1,000. As simple as that. So that will be the concept for population and sample. Okay, my ear is hurting me, yeah, because the my what we call that the earphone. Okay, stretching my ear. Okay, now next, let's move to the particular slide. Okay, how statistics help. So in this case, by identifying the correct terms for your data, it will help you in your analysis. So in this case, the length is considered as variable, and you may also refer to your what we call internal ring from your textbook, and you may have the what we call internal diameter, external diameter as the variables for this particular ring here. Okay. Now, whenever we say population and sample, of course, we know now the distinction between population. Population is all the entire subject of my study. And my sample is subset of the subject of my population. Now, when we have this particular distinction, we will also have specific notation that reflect data collected from population and data collected from your sample. So how do we define this from population and from sample, and what do we name them? First, we call them as parameter. Second, we call them as statistic. Bear in mind here, class, there is no S here. So it turned out that this is spelling mistake. So whenever you refer measurement from your population, that measurement are called as parameter. When you measure from your sample, that measurement is what we call statistic. And what are the notation for parameter and statistics? Let us see. Let's say we are talking about the size of the population, the size of sample. What is the notation? For parameter, the size of population is capital N. The size for sample is small n. What about mean? What is the population mean? The notation for population mean is mu. The notation for sample mean is x bar. The notation for variance population variance is sigma squared. Sample variance is s squared. The same goes to standard deviation, okay, and so on and so forth. So these are all the things that you should understand. When we say parameter, it reflects this particular measurement. When we say statistic, it reflects data from your sample. Okay. Now, if we focus these two into what we call the population and the sample, so this is how it looks like. Okay. We have our population where we call them as parameter, and we have the sample where the measurement we refer as statistic. Now, why are these important? Why do we need to have sample? Okay, class, imagine if we go back to the skewer example just now. How many skewers in a day the production made, class, just now? Can someone reply? How many production for one day? 500,000, right?
500,000, sorry.
Yeah, 500,000 means that 500,000 one day production. So are you going to use your workers to measure all the length for 500,000 skewers produced in one day? Are you going to do that? No, definitely no. Because in statistics, we believe that when you choose a subset of your population, it's actually representable of your population. But there is but here. But when in order for you to choose sample to represent your population, there will be some statistical procedure that you have to follow. But in your case, disregard that. Okay, assuming that you choose your sample from your population and your sample that you choose is representative of your population. Now, in simple words, we can say, by choosing sample, we actually minimize our time. We reduce our money. We reduce the cost of doing the measurement, doing the study. We reduce the time. Okay, so actually statistics help you out in terms of reducing your money, your resources, your time, in order for you to study the whole population that you wish to study, but using the subset of the population that you have. Okay, I hope everyone understand. The statistical inference, later on I will explain that in detail. Now, I have also few distinction between parameter and statistic. I want you to look at it on your own. Okay, so it is clear, but somehow I think I just touch it at this particular example. For parameter, as you can see here, in 2010, the population of the town numbered about 5,000. So here you can clearly see from the example, the population mentioned in the example. So you know that you are talking about your 5,000 is actually what? Small n or capital N plus? This 5,000. Small n or capital N?
Capital N.
Capital N. The same goes, the city has a population more than 1 million. So this is your capital N. Again, there are 305 doctors in the hospital. This simple statement reflects the population. Means that capital N for doctors in that particular hospital is only 305. As compared to statistic, means that you collect your sample. Okay, so what will be the hint for that particular so-called sample? According to a survey of 606 city residents, garbage collection was the city service people like most. Means that 606 is actually a sample of the population of city residents. Okay, so the keyword is what we call is described by the surveyor. When you do survey, means that you are collecting your sample information. What if you wish to collect your population information? Do you use survey? No, we use census, CENSUS. Okay, so this is what Department of Statistics, every country do for every 5 years. They will perform census for their population. So this the first example. Second example also the same. The word survey shows that the data 2000 is your sample, and this 2000 is actually your small n. Okay, so that will be the distinction between parameter and statistic. Now we have covered what is variable. We have discussed about what is variability. Then we have population. We have sample. The second last two will be descriptive statistic and inferential statistic. Okay. What is descriptive statistic? The word descriptive is actually coming from describe. What is describe? You tell about you tell the way you tell, how you describe. Are you going to describe by certain features? What that features that you are going to use? Okay, so this is all about how descriptive statistic can help you out with your data. You can come up with something good information, meaningful information. So descriptive statistic is used to describe basic features of data by providing summaries. Okay, means that from your data, remember, collect, organize, summarize, then analyze. So before you can even analyze, you have to summarize. So how you summarize? You can use graphical or numerical approach. So it depends on what is your objective. Later on you will see how we can differentiate when to use graphical and when to use numerical. Okay, so descriptive statistic is all about how you can describe your data into a meaningful information. What about inferential statistics? Okay, Inferential statistic is making inferences about the population using selected sample. The keyword there, using your population. Okay, you know that you wish to conclude about your population, but somehow you don't have enough money, enough time, enough resources. We use the sample, and by using the sample, we want to conclude on the population. That's why the process becomes this way. From the particular population, we choose our sample. Once we choose our sample, we have the sample here. By using the information from the sample, we wish to conclude about our population. This is the process of statistical inference. Okay, so more on statistical inference will be discussed in chapter 2, 3, 4, and 5. Okay, chapter 1 covers descriptive statistics. Now, what are the process in descriptive statistics? Okay, first, collect data, organize data, analyze data, presenting data, interpreting data. So this will be the what we call the processes that you will have to do. Okay, in order for you to do or to perform the descriptive statistic. Okay, now in addition to what I have mentioned just now, inferential statistic is used to perform estimation, hypothesis testing, determine relationship, and making prediction. So you can see, unlike descriptive statistic where simple process involved, what happens when we are talking about inferential statistic, you will go back to the concept of statistical literacy, statistical knowledge, statistical thinking, statistical reasoning. So this is where the four statistical concepts are very important to be used in your making inferential or in statistical inference. Okay, so that is why you will have to use all the four concepts of statistics when you deal with inferential statistics. I think you can read this. Okay, just to highlight, inferential process is to make conclusion for population using sample. So means that using population, we select our sample, and using the sample, we make conclusion of our population. The same with what I have discussed just now. Okay, now done with 1.1. That is introduction to engineering statistics. Any questions so far, class? It's almost 1 hour. Huh? No,
No.
no. Okay. We move to the next part. Okay. I hope we can finish until 1.3 and then we can stop. Okay. Now, assuming that you are the engineer, okay, and you have to collect your data. Okay. And somehow it turned out from your what we call study, you will have to perform both. Okay, you have to come up with your own experiment, and you will have to select or collect your own data, first-hand data that you yourself collect. And maybe you will have to use available data. Okay, and how do we what we call classify these two data that we have? Now, we can say that into two types of data source. First is what we call primary data. Second is what we call secondary data. As the name appears, primary means first hand, so means that all the data is you yourself collect. Secondary data is readily or available data, and you can have that through the internet, through the report, newspaper, and everything. Okay, so what are the methods for you to collect your own data? You may have survey. As I mentioned earlier, you can see the word survey. Survey means you are going to distribute questionnaire to the respondent of your interest, and that will reflect your sample. Okay. Survey is actually last time we do it person to person. Then we have telephone, we call them, call to call. And then last time we have email, we email them. Nowadays, these are not no longer the case. You have Google Form, you have IG, you have Telegram, you have WhatsApp. So you can just simply do your survey using that particular platform. So all that is considered as survey. Okay? Observation and experimental. I guess observation and experiment is like a twin. Okay, once you do experiment, of course you will have to observe. But in social science, there is a specific what we call observational study. Means that they will just observe the respondent that they are interested in. They just observe and they take note of the behavior of that particular respondent. But in your case, when we do experiment, okay, maybe in the laboratory or maybe in terms in the manufacturing or whatsoever, okay, so when you do the experiment, of course you have to observe the experiment. Okay, how does it change, how does the changes takes place and everything. So at the same time, observation will happen when you do the experiment. That will be all about primary data. What about secondary data? So there will be a lot of sources, especially nowadays. So some of the sources for secondary data would be library, okay, maybe electronically or using the what we call reports, available books or data and everything. It could be government reports, it could be from trade professional and businesses, okay, so on and so forth. So there will be many sources for secondary data depending on what types of data, so you will have to pinpoint which sources or which source that will be suitable to look into. Now, I'll just quickly go through to this particular collecting engineering data. So how do we collect? As I mentioned earlier, when I discussed about the statistic process, more or less the same as this one. Okay, when you need to collect your data, of course you need to formulate your questions. And if we are talking about survey, so this is the first thing that you have to do. Formulate the question. What is the data that you need? If you're talking about, I need the weight of my respondent, so you will ask about the weight. If you're asking about the height, then you will ask the height. So that will be the question that you need to formulate earlier when you do the data collection. Then once you have done with the questions, you collect your data. How? Could be using Google Form, could be email, could be WhatsApp, whatsoever. Then once you have got your data, you analyze them. And then finally, you will interpret the result. Okay, more or less the same process. Now, in order for you to collect your sample in statistics, this random sampling is the most common one. Okay, of course there are many other what we call sampling procedure, and we will see some example of that. But random sampling is one of the way, okay, of selecting a sample where each individual in the population has an equal chance to be included in the sample. So means that if I have 100 what we call respondent here, how I want to choose, let's say I need to choose 30 out of 100, equal chances of selecting each and everyone inside the population. Means that if I choose him, the probability is the same as I choose him. The same as I choose this guy. Okay, equal chances to be selected. Okay, of course there are procedures related to this, but I'm not going to discuss this in detail. Okay, so there will be few sampling methods. Okay, just see on your own. Okay, and then okay, further details for your observation study and experimental study. Okay, what about observation? What about experimental? Okay, in observation study, researcher needs to observe and measure specific characteristic of variable. Of course, when you do observation, it is a first-hand data, so you do it on your own. So if you are going to measure, you will measure. Okay, you will have to measure. and no attempt to modify measured variable. Means that you have done measuring, you have got the data, the value, then you put the value in the table. You are not going to modify them. Okay, so that is observational. So how? You can use survey or you can use observation. What about experimental? How does experimental differ from observation? Researcher in experiment makes attempt to impose treatment on subject and they observe the effect of treatment on subject. Means that you need to see what will be the changes towards the subject. Okay, let's say if you're talking about trees, you have a land where you have different let's say durian, musang king durian planted in your orchard. Okay, what happened? You have 100 musang king trees, and you wish to know which fertilizer is good for musang king. So you buy 3 different fertilizers. So what happened? The treatment is your fertilizer, the subject is your musang king tree. So you will put different fertilizer from your 100 trees, musang king trees. So in few months later, after the first season, once you put the fertilizer, you wish to see which of the trees, musang king trees, will give more musang king fruit from different fertilizer. So in this case, this is where you put an attempt to your subject based on the treatments that you choose. Okay, and you wish to see the effect of that particular treatments on the yield of musang king fruit. Okay. Okay. Are you all okay? Are you all okay?
Yes.
Okay.
Okay. If that's so, I think I'll just stop here. Is it okay?
Okay,
Okay.
madam.
Okay. Now, what happened, class? For next week, beginning from next week, I will prepare short videos because I found out lengthy video, for example, in this particular class online, is not really what we call a good idea to have what we call organization of online classes. Okay, because my last time teaching this subject was in 2018, so most of my slides were old version. So we have already referred to the new version of the textbook. So everything has been updated. So what happened is that starting from next week, there will be sync and async class. Okay, I will prepare few videos. I will just prepare the list will be 5-minute duration. The most will be maybe 15 to 20 minutes video. And it covers the sub-chapters of our textbook. So it will be easier for you to rewatch the video again and again if you don't understand. So I'll try my best to prepare the video, short video, and it covers all the subchapters in your textbook. And what we do during the sync class, like today's class, we are going to discuss on the questions, on the things that you don't understand. I like to try that way. Let's see if it is good that way, and we will proceed until the semester end. Okay. So I really hope I can, share the videos one by one, short videos, and I will just upload it into my YouTube channel so that you can easily access from there. Okay. So last but not least, do you have any questions? Last but not least, do you have any questions?
Yes.
Okay.
Doctor, do we have finalized them?
No, all it will be continuous assessment. As I mentioned, there will be 2 projects, there will be quizzes, there will be tests. No assignment.
Okay, thank you.
Okay, because I need to mention, even though we easily have tests, quizzes, and project. Out of EQT101, 102, 203, EQT271, most of the time the normal curve is for EQT271. There will be less student very good. There will be less student not good. and there will be more students in the average, what we call average achievement. So even though we have this particular assessment, simple assessment, but most of the time, if you don't equip yourself with all the 4 statistical concepts I mentioned earlier, it will be hard for you to score this subject. Okay? Any more questions other than that?
Doctor, I want to ask about the mini project.
Okay.
You have already given us the data, so do we need to like find our own data or just use the data you have already given?
Yeah, you know what? I spent 3 weeks and my team, my colleague prepare the data and to prepare the instruction and the rubric. So what happened? We make it easy for you. So just use the data that you select, and once we finish covering chapter 1, we somehow you can start looking at the data and you can start thinking what would be the things that you need to analyze from your data. So you don't have to find other data. Just use the data that you choose. Okay?
Okay, thank you, Doctor.
Okay, thank you. Any more questions?
Puan,
Yes.
apa nama dekat master list tu kan? Saya ada confirm dengan Puan semalam dan bila saya view balik sekarang, nama saya betul tapi nama teammate saya tu tak betul.
Aduh, hold on, hold on. Okay. What name is that?
Nama saya Muhammad Rafiq.
This is my master list. Muhammad Rafiq. Where is my master list?
147.
147.
Yeah.
This one.
Yeah. My partner name's Muhammad Irfan bin Salahuddin.
I copy this from your. So not Irfan Afiq,
No, Muhammad Irfan bin Salahuddin.
Okay, is Irfan Afiq here? Irfan Afiq, can you respond?
Yeah, I have a team.
Okay then. Okay. What is your team, Rafiq? I settle Rafiq first.
Ya, Muhammad Irfan bin Salahuddin.
You are RK86, right?
Ya, RK86
Muhammad
ya.
Irfan
Bin Salahuddin.
Muhammad Irfan. Can you trace for me? Irfan Afiq. Irfan Salahuddin. Okay.
Ya, that one.
Okay.
Ya. Ya.
Control C. Here, right?
Ya.
Control V. And then
Memetrik 191032404414.
okay, yeah. Control C. Control V. Just now, Afiq, Irfan Afiq, what's your name? Have you chosen your data?
Yes, ma'am.
Which number?
Tajuk dia zakat.
Zakat.
D.
Yeah, it's this one.
Ah.
Luckily I have that correct. Thank goodness. Okay, thank you. Done.
Okay.
Any more questions?
Doktor.
Yes, I'll just stop recording first. Okay.
Doktor, saya
Yes.
isi master list